Hello, this is section 3.9 related rates topic. In this section we're going to talk about the applications of derivative in real life. No new concept, no new formula. This is all about discussing some exercises that will show us how we can use the rate word or the derivative in real life. Let's start with this example. So air is being pumped into a spherical balloon so that its volume increases at a rate of 100 centimeter cube per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeter? In fact, this is an interesting case where we have the balloon as a sphere shape. So this is gonna be spherical shape. So this spherical shape, in fact, they give us the rate, where the rate indicates the derivative with respect to the time. So the rate of the volume on which the spherical balloon had, it was 100 centimeter cube per second. And now when they're asking about how fast is the radius, it means what is wanted is the rate of the radius. So as we said, rate indicates the derivative. Let's look at what is given to us. In fact, we have that the rate of the volume with respect to t, so we can say it's dv over dt is in fact 100 centimeter cube per second. And also we are given that the diameter is 50 centimeter. To just let things relate to each other, let's write the volume equation. The volume equation of the sphere is going to be 4 over 3 pi r cube. In fact, let's write what is the unknown. So in fact, we need the dr over dt, which means we need the rate. This indicates the rate of how fast the radius of the balloon was increasing. And here we are given that the radius is 25 centimeter. This fact can be brought from this diameter. So as we discussed before in earlier sections, in this case we have to differentiate it implicitly. To differentiate this implicitly, we have to start from the left hand side, saying that it's dv over dt equals to 4 over 3 pi multiplied by 3 r square multiplied by dr over dt. Since we consider r as a function of t and we're differentiating it with respect to t, there are some simplifications that can be done. So this is equal to 4 pi r square dr over dt. Now since we want dr dt, we have to solve for dr over dt, which is the rate of how fast is the radius of the balloon. So to take this to the other side, we have to divide the two sides by 4 pi r square, which means dv over dt will stay on that side, and here we'll multiply by 1 over 4 pi r squared. Let's write things down using the numbers that we have. So in fact, dr over dt is going to be dv over dt, which is 100 multiplied by 1 over 4 pi multiplied by r square, which is 25 square. In this case here, we just have to simplify some. So it will be 1 over 25 pi. So this is how we found how fast is the radius. So the rate, let's have a look at this example where we have a water tank that has the shape of an inverted circular cone. So the shape that we have here, in fact, is a circular cone with base radius 2 meter and 4 meter. Okay, so let's just draw the shape that we might have. So it's going to be a cone that looks like this. This cone has a radius of 2 meter and a height of 4 meter. So there is a water that is being pumped into the tank. Let me use blue for this. So the rate of which it's being pumped into is 2 meter cube per minute. We have to find the rate, where the rate describes in fact the derivative at which the water level is rising, and when the water is 3 meter deep. So this is the cone. We know things about it, but there is also here something that we have to know, is that there is water here. Okay, so this water in fact is 3 meter deep. The equation of the cone, which is 1/3 pi r square h. In fact, we have now to write the given things to us. So starting with the first one, we know the height of the cone, in fact it's 4 meter. Now the radius of the cone is 2 meter, and what we also know is the rate of the rate of the water in which it's being pumped into the tank. So in fact this gives us not the volume but the rate of the volume with respect to time, so it will be 2 meter cube per minute. Now we have to find the water. This is what is unknown. In fact, we have to find the rate at which the water level is rising. So this depends on the height, in fact, but the rate of the height with respect to t, what is it? We don't know. So this depends on the height, in fact, but the rate of the height with respect to t, what is it? We don't know. Also, we are given that the height of the water is 3 meter. In fact, if we look closely to this equation, we can differentiate it implicitly to get what we don't know, which is dH over dt. So in fact, let us just look at it. We have here the variables that we have are v and r square and h. Let's have a look at them. In fact, v is known for us. So to find h directly, it's better if we replace this h, which is the radius, if we replace it by an expression of h variable. So let's see how we can do this. In fact, we can do a proportional equation. So we have r over h, which will give us 2/4. So I can say that r is something of h, so we can write it in terms of h. 2/4 in fact is half, so here if we take h to the other side, it will become h over 2. So now we can replace r with h over 2. Let's see how we can do this. So now in fact we have that r is h over 2 and we have this equation that is v over 1/3 times pi times r square. Instead of r square, now I can replace it with h over 2. So this is squared, here it's multiplied by h. This also equals pi. So here we have h square multiplied by h, it's going to become h cube over 4. So in fact this can be written as pi h cube over 12. So let's differentiate this implicitly. This will become dv over dt equal to 1/3 pi multiplied, in fact here we have a 12, so we can take them out. So 3h squared multiplied by dh over dt. We're considering h as a function of t, which is a differentiable function, we will solve for dh over dt. So if you want to solve for dh over dt, we have to move these to the other side, which means that we have to divide by the other side. So it will become dv over dt times 12 over 3 pi h squared. We know that dv over dt is 2, in fact, multiplied by 12 over 3 pi, and the h, this h represents the h of the water, which is 3 squared. To simplify, we have 12 over 3 is going to be 4. So here we have 8 over 9 pi. And that's all, in fact. So this is how we got dh over dt, which is 8 over 9 pi.